So this is the last session of the morning, and we are going to talk about large-scale deployments. Not just because all these deployments are large or huge or hyperscale, but because many organizations, many enterprises are going that direction. So last year, I attended a supercomputing summit, thank you to Molly, and I had this impression that enterprises are adopting HPC technologies and other cloud-like technologies, Google-like technologies a lot. And it's happening very fast, okay? And, in HPC world, they are talking about exascale now. It's impressive, okay? And, but we are talking daily about petabyte scale in medium-sized organization now. And it's changing very quickly. And we have a problem of performance, of capacity, of networking. Networking architecture are changing drastically, okay? So the first question is for Tom, because we had yesterday this conversation about different approaches to software-defined networking, and they are not all good, okay? Sometimes it's about performance, sometimes it's about programmability, sometimes it's whatever, it doesn't fit in the right architecture, okay, in the right design. So my problem, I didn't understand actually. So a few years back, software-defined was sold like the holy grail of networking, but actually it's not that easy.
No, it's not. It's, and it's actually, I'm going to be talking a little bit about that later. Software-defined no longer means cheaper, faster, and done by robots. There's a whole lot of other things that go into it now. And at first, the reason why we had to sell it that way is because we were trying to get people off of the network hump, which was, I can scale as fast as my admin can type a command in a notepad and then copy and paste it into 15 switches. God forbid I typo that command or I paste it into a production switch instead of the dev switch and blow things away. Now, we're still running into those issues because people still don't get how they're supposed to program. There was a story that came out just about a week and a half ago where a guy did a production run where he upgraded 57 switches and realized that when it completed and they all rebooted, that he had used the wrong firmware image. And the command that he used to copy the firmware image over didn't know that the switch image was wrong until it rebooted and said, oh, guess what? Nothing. So that was probably a resume generating event for him. And what took me more than anything else was the fact that nobody blamed the tools. It's like, you're an idiot because you did this wrong. And that's what we're starting to see in software-defined networking, is that when we're trying to build things at huge, huge scales, we can't rely on people anymore because people are dumb, panicky animals. And software-defined scripts allow us to do things in a replicatable fashion. And, Justin said, in order for us to be able to do things quickly at large scale, it has to be the same every time. You cannot have square donuts coming off of the assembly line because then you've got a problem.
So you are working a lot with this scale-out kind of systems in the hyperconverged space. And so is the kind of skill that we need to do that, is it changing? So the sysadmin needs to be more a coder than in the past, or is just...
Yeah, absolutely. You see sysadmins are starting to work higher up in the IT stack. So they used to, like Tom said, configure a switch directly. Then they'll implement a tool to configure a bunch of switches directly or as a group. And now you're seeing they're moving up into the more logical space where they don't actually interact with switches anymore. They just set a policy or make a decision that causes an orchestration engine to kick off a workflow to configure the switches in line with the policy that's been made. So you see admins working on a more logical level instead of a physical level.
Yeah. So infrastructure is becoming more transparent to this. Sysadmins.
I'd almost say invisible if one specific vendor hadn't taken that in their marketing message, but it is becoming invisible.
Yeah, but what does it mean? So how can you manage all this? And this is for you. How can you manage all this transparency? Because you lose control on what's behind this layer of invisibility. Actually, do you have probes? Do you have something now that is happening at the upper layers to manage, to monitor, to understand what is happening?
Yeah, so what we see is that when you deploy at scale, what's happening is sysadmins are now having to understand applications more, right? And so when they're trying to optimize, it's not a one choice fits all type of thing anymore, and they are more learning about their applications, trying to understand how best to do something for a particular application, right? And then kind of bringing that in. And at scale, you can't do that for every single application, so you need to then start automating some of that. So we see that people are building workflows that allow them to bring that knowledge into the infrastructure and kind of automate those workflows.
That's really interesting. And also another thing that I noticed that Supercomputing Summit was the fact that now many vendors are working on going beyond the traditional technology like file system, for example, because they are becoming a real limit in certain kind of application like Internet of Things, for example. So does this kind of application knowledge that we need to have to understand also helps in the scalability on the infrastructure, because now we have different kind of storages that are ready to accept any kind of data, but actually how we can leverage this capacity or at the same time the performance, can we really decouple the two?
Well, I think it really is about us becoming more software-defined in everything that we do, right? And so software-defined means how do we actually take control so that an application developer, a DevOps person can actually control the infrastructure. And that means down at the storage layer, we need to have almost self-describing data. You don't just store data as bits and bytes anymore that are carried up into a file system. Your data should be self-describing. You also should be able to run analytics on that data. You should be able to have indexes on that data. So I think your new type of storage system is going to be a scale-out, software-defined storage system. It's going to have the ability for data to be self-describing, and that data, because it's self-describing, developers can actually go and use that and can do stuff with it. You can migrate, you can move data, you can move it up to the cloud, it can be portable, it can be self-described. It's essential that we try to treat data like self-describing objects, and we build scalable systems based on that. And I think that whole infrastructure is going to change. Somebody else said it was going to become, I think there's storage is going to change. It's going to change into this scale-out, hyper-scalable, object kind of oriented storage system. And then somebody said persistent in-memory technologies. It doesn't look like a storage array anymore. All of your databases, all of your transactional I/O, all that will sit up, and you'll effectively archive and move data using this fabric layer, which is your object layer. So, but all something that software developers can then consume and use. And
Molly, your company is very strong in the HPC market, right? But now, lately, you are working a lot also in the very high-end enterprise with specific analytics application most of the time. So what are you seeing at this level? Because these are probably large infrastructure, large deployment. They are using technology that a few years ago were unthinkable in that kind of companies. They are changing their mind.
Yeah, what DDN has seen is we've been selling into Petascale environments for decades now, so we know this environment, and technology doesn't behave at scale the same way it behaves when it's not being challenged. A 500 terabyte file system just behaves differently than a 2 petabyte file system, for example. And the challenge, there's really two things that we're seeing that DDN is helping the enterprise with. Our HPC background has made it possible for us to help the enterprise who's now challenged with these things is, as we all know, users and applications change very slowly. In fact, they don't change at all. We're using the same applications that were written 30 years ago today on all the fancy new technology that we're building. And so you have to have some kind of software layer that knows how to translate old applications into new technology and have the I/O move properly, have the data management move properly. So that's a piece of it, is how do you solve this I/O problem that we have and the application problem in the data center? And then the other piece is the data management piece, that just throwing a fast flash array at a problem sometimes may be a shim, it may solve a problem, but then you have a bigger data management problem because you now have another set of technology you have to manage. So this data management of a petascale type of environment is very different than data management of 50 terabytes of Exchange, and that's what we really specialize in.
So, and also, I don't know how many of you are experiencing this capacity growth that is always mentioned in any presentation from any analyst. But actually, what are you seeing, and what can you ask to these guys about your infrastructure? What are you seeing in the field? Because I had a lot of experience in the last year, just in the way, for example, in Italy, I have a customer. It's a small bank. They are migrating everything, all the remote offices to sync and share, which is it's not very large in terms of terabytes, but it's large in the number of installation, in the number of clients, in the number of small offices are accessing. So it's not only the size of the data, but actually the dispersion of this data on the field. Are you experiencing something like this in the mobile environments? What are you seeing? So in this new complex installation, so is mobile a real problem? So this difference between the local data that you are in a data center and the data that you see coming or back and forth from mobile devices. I don't know if you...
I think it's a huge problem. We have all this big at scale technology, but how do you get the data into it and how do you get the data out of it for each user is a constant issue that we hear about. And mobile data, whether it's your PCs or your iPhones or whatever it is, being protected, but also being able to share that data somewhere else is a huge issue. And I think that as technologists, we often worry about, here's our fancy erasure coding and the way we scale our systems, but really to the user issue, it's all about, somebody said on the last panel, they don't care. I mean, the geek of them may care. I think it was you who said this. But ultimately, it's great to know that your storage vendor knows how to handle these problems, but how do they make it super easy for you? That's become a bigger focus of how you handle the user data than the storage systems themselves, and it's very important.
So
and
it's
hard.
also changing the way we are transferring data. Now HTTP is actually a storage protocol. If you think about
Sure.
most of the mobile devices are working with HTTP. They don't use NFS. So how does it impact the way this system can scale? Because it's networking actually, but it's storage. It's no more FC, it's no more, so.
Yeah, I mean, I think that is a big thing, right? So now all of these devices, they talk HTTP, right? We look at the whole IoT and that evolution of that industry. What we're building is big infrastructure, as a man from Cloudian, and we're building a big infrastructure that really is a RESTful-based interface into that, and it's also geo-dispersed. So we're able to build a very powerful infrastructure that can actually just feed your data straight into it. We're building cameras and security systems that are all HTTP and IP-based systems. So you're going to see that the backbone, as I call it, that data fabric becomes this IP-based backbone. How we communicate to it is RESTful interfaces. Most likely one, I think, as Stephen mentioned earlier, is an S3-based protocol as a way to store and save data. And a lot of the sync and share applications, the new sync and share applications, already interface in that. So there's a whole ecosystem of applications that are already built around that ecosystem. So I think the whole world is changing.
Yeah, but also the data center is changing very fast. Now we have now vVols from VMware. Now they are eliminating pieces of the IO stack, and they are going directly.
Yeah, so I have a slightly different perspective on this. So prior to PernixData, I spent many years in the database industry, and someone was talking in the previous panel about moving the application to the data as opposed to moving the data to the application. And if you look at the database industry, they try to do that, where they have this concept called in-database analytics, where you can write your analytic modules and push it inside the database. So the application goes to the data. While that worked for some extent, it was not quite successful, partly because you introduce bugs when you do that, and it's proprietary APIs and all of that, right? So I don't know if that is a scalable way. Now talking about the disparate data sets though, What I think what's important to understand there is, even from the database world, I had the same learnings, which is the disparate data may be all over the place, but what is relevant to the application is what matters, right? So you may have 100 petabytes of data, but what matters to that database may be only 200 gigabytes of that for its day-to-day operations. The point is you need to get those 200 gigabytes right next to the application. So intelligence in the storage system to move the data that's relevant to the application right next to it makes a lot of sense, irrespective of how disparate the data might be.
Yeah, but then you need a lot of analytics to analyze the data set, to understand
Correct.
what it's out, what is not. And
Correct, that is true.
So data locality is
Correct.
really important. Sometimes I heard that data locality is not important because, that now we are thinking about this really scale-out system, and you don't know where you are writing, but actually you can get many hops to get to the...
Correct. Not only data locality, but spatial locality as well, because you want, sometimes data is accessed in very frequent time periods, so you need to understand both.
So, coming from the field, do you see this happening? So data locality or this kind of things, how the vendors are
So I actually have another different perspective, which is kind of colored by me visiting FOSDEM, an open source conference last weekend. And those guys, it's all developers who attended that conference. And they're all looking at it from a completely different perspective. So what they'll say is, as long as I've got an NFS share or an S3 compatible object store or something to work with, like Justin said, as long as I can store my data somewhere, I'm good. And most of the developers there are actually in that same boat. They don't care about anything behind the scenes. As long as they can access that 200 gigabytes that is relevant for my application at any given time, they're good. So they're actually building into their application layers all these types of logic instead of implementing it on the infrastructure layer. And that's a whole different perspective to look at it, because the applications and the application developers are now solving their own data issues, if you will, which creates an argument for the infrastructure people to not have to care besides just storing it in a persistent layer anymore.
Yeah, but many applications are not ready to do that.
Absolutely.
So and Tom, you know that this application can be very painful to manage, especially with the traditional architectures in the networking. And we are seeing this network going flatter and flatter. And so my question is, how much is important to have these new designs? Because we are talking about a lot of different technology in the data center, but actually I don't understand today, are all the pieces of the stack following the same path? Or are you seeing differences in how networking is implemented and storage? And 2 years ago it was all spinning disks, and it was the bottleneck.
Well, yeah, I think what you're starting to see, as members of the panel alluded to already, is that we're hiding all of that. How many people in here have an AWS account and use it regularly? Quick question, when's the last time you configured a port profile on AWS? Better question, can you find where to configure networking in AWS? Or is it just a little checkbox that says, let this talk to that? How many of you can find the IP address on your iPhone? The geek in you can find it, but the applications that you're using don't care. And that's, I think, where we're starting to see the stacks come around, is every time you have somebody come over to your house, you don't have to re-provision your plumbing system, right? It just works. It's a transport mechanism for stuff. That's what the network and the storage system and everything in a hyperscale and a large-scale environment should be. It should be a transport medium, or it should be a storage medium that we don't have to tweak. The reason why we had so many problems in the past is because the application developers believe that their application is immutable, that you need to fix the infrastructure to support my application. And thanks to companies like Netflix and other people who are deploying large applications at scale, they're stepping back and going, no. The application has to change to meet the requirements of what we're trying to do. Think about all of the crazy things that we've come up with in networking and storage. Availability, active controllers for anything. That's the dumbest idea in history. You are basically, the idea of an active controller is I'm driving two cars down the road parallel to each other at the same speed. So in the event that I get a flat tire in this car, I can immediately jump over to the other one and keep driving. Stupid. Why don't I stop, fix the problem, and keep going? The application should be able to recover from stopping to change a tire. But we have been doing dumb networking tricks for so long to support applications that are stupid that we can't see past that.
Yeah, but the problem is that we still have those applications.
Exactly.
So my question,
But they're starting to go
was
away.
about, so if you have an application written 20 years ago, and it's still the core of your company, and you can't, I met a guy a few weeks back. He was retired, I don't know, 2-3 years ago. He's still there, managing COBOL stuff for the company, and he is now charging like 2,000 euro a day.
Oh yeah, and he's
because he wants to go fishing, and they call him.
Well, okay, so if your company depends on a 20-year-old application to do its line of business, go out of business.
I don't think that's not realistic, though. I mean, the biggest companies in the world are like this.
Let me ask you this, Molly. Why is it not realistic? Would you drive a 35-year-old car to work?
Sure, but the point is, if you look at a proprietary trading firm in financial services, they make some of the most money of any company in the U.S., and they're not going to change their application because it works, and that's their IP. And I think it's the big difference of these companies that data has been their business for so long. The application does rule. And then there's this new version of applications that's coming out.
So let's take in-memory computing, right? It's in vogue, right? You look at every application that's building in-memory capabilities, right? Everybody's doing it in a proprietary way. So SQL Server's way of doing it is different from Oracle's way of doing it, is different from Memcached way of doing it. And now, if you want to leverage that capability in SQL Server, you need to upgrade to SQL Server 2014, rewrite all your applications. Why would you have to do that, right? I think moving what is an infrastructure requirement into the application means adding complexity, becoming more proprietary, and you're just moving the problem around, right? I think there's a cost is moving, but you haven't solved the problem.
Yeah,
right?
but I think that
not actually improving your application is creating technical debt, which in the long run will create.
Yeah, no, that's fair. That's fair.
It'll create situations where you're trying to run AS400 green screen applications over T1 lines 3 states away, expecting local area network latency and wondering why your application freezes every 30 seconds.
Right, but I think we're still going through an evolution here. I mean, we all would like to see us move from, the pets kind of environment where application-centric deployments. That's what we built. To a much more open, scalable kind of infrastructure deployment. I mean, we know that's where we want to get to. The good news, though, is application developers are changing too, right? The backup apps are already writing to S3. So most of my infrastructure, I didn't custom write most of my applications deployed in IT today. I use some third-party application. A lot of those third-party applications are getting rewritten to use RESTful interfaces, to use infrastructure the proper way. And that is the side path into this. The other thing that we've done is vendors like us and many others have gone and built interfaces that allow you to use NFS or SMB, and so it looks just like any other storage protocol that you would have used before. We're in a transition mode, and we can't expect all developers to switch over and rewrite all their applications. The Googles and the Facebooks and everybody else can do that. It's going to take time, and I think it's going to be application ISV driven to make that change.
They started with it, right? They already, when they developed their application, they had that in mind.
Right.
And you're not going to do that if you already have an application that runs for so many years and it's doing its work. You're not going to do it like that.
Right.
It takes time.
You're right, it does. How many people in here still use old apps on your iPhone? How many of them crash daily because they don't support iPhone 7s or whatever's coming out next week? I mean, hell, think about all the applications that were written for Macintosh before, 2005 that won't run on new Macs because the OS won't allow PowerPC code to load anymore. They stripped that compatibility layer out because
but
it's
I think
debt.
So, and then we will
Yeah.
wrap up. But I think that
Just getting in.
it's not fair to compare an iPhone to a mainframe.
That's right.
Okay, so it's like saying tape is dead, no? Because yeah, I was using tapes to back up my PC. It was a small DAT from Sony, you remember? And it worked at the beginning, yeah, not all the time. It saved my life a couple of times, okay? Now, I do a copy on the cloud. But because I am alone, because I am an application, because I can vast a lot of time migrating data. I migrated, in the last year, I migrated from Google Drive, not from Dropbox to Google Drive to OneDrive, okay? You could ask why. But that's another problem, okay? So it's 200 gigabytes over an ADSL. So it takes like 3-4 weeks, right? And I can do that. Try to migrate tons of old data with old applications. Sometimes the formats are not compatible from a cloud, from a storage to another. I'm not saying a cloud to another. Just try to migrate tapes written 20 years ago. It's not that easy. So there is a long tail.
It's a long tail.
But I appreciate your time and thank you for all your comments. Any other questions? One more?
So I heard a lot of talk today from several different folks about changing your application to run in the cloud, and that kind of theme, right? But we're not seeing that. What we're seeing is Exchange dying for Office 365 and OneDrive. We're seeing Adobe abandon the massive portfolio that they've built up for Creative Cloud Suite and go into these subscription models. So I guess I want to understand what the hell everybody's talking about when they talk about recreating applications to run in the cloud, because I don't see it happening, guys.
They are. They are building a 10% faster horse that eats slightly less hay.
Who's they?
They would be application vendors who are being forced by their customer base to adopt mobile applications. And when I say mobile, I don't mean running on phones. I mean applications that can run in different places that scale so that 50,000 people can log on to Photoshop to put Donald Trump's face on something and it won't crash. But they're selling things to customers that they want, which is the old interface running in a web browser. Customers don't want revolutionary. They want evolutionary because they want the same comfortable things that they've always been using. They just don't want to be tied to one machine to do it.
Yeah. I think what we're seeing in customers, we see some customers and big financial guys are ready to write their own applications and been doing it forever. Many other customers don't. But what they do have is net backup deployed, Commvault deployed. That's their backup infrastructure. They can just drop in a different low-cost storage interface underneath that, they'll do it. If they're trying to deploy something new where they want to sync and share, they've never given the ability for people to have mobile device access to their files. There isn't good ways to do that off a NetApp system today. They'll deploy a new application. All of those are written RESTful based. So I think what you're going to see is selective areas where this is really powerful today, and then you'll see it broaden as we get better in the ISV community.
One more question? Yeah?
It's not a question, it's just a comment. Thinking in the, not only in the application, in desktop or mobile, thinking in the game side, many companies, Microsoft, Electronic Arts, Blizzard, many companies for games, is migrating their games' traditional infrastructure to the cloud. In this case, it's Azure, Google Cloud, Amazon even. So it's not only migrate your Microsoft Office to Microsoft 360. It's not only application, it implies many things. It's not only recode the application. You need to think in cloud, that means the database need to be in cloud, the caching need to be in cloud, session need to be in cloud, migration need to be in cloud, networking need to be in cloud, because at the end, the goal for the cloud is try to get 100% of time. Avoid that downtime. In thinking in deploys, what is the topic in this talk? The deployment need to be in cloud. That's the point. Because the traditional, it's not a Python fabric script will deploy everything. You need to use many tools to get that goal, the uptime or the downtime.
Yes.
Thinking in the games also, not only applications.
Good. I think that with this, we can close
Yeah, I
this.
think we're
panel.
way
Thank you.
over time.
And we are all hungry. And okay, the lunch is served in the downstairs here on the left. There is a room, large room for us. So that's it.